Last section, turning zeros back into equations. Here's the good news. We have done this before when we did quadratics, right? We gave you the zeros. We remembered that it has to be an equation, right? Those are both positive. Wait, what did I do? Should I start again? X minus 2, x plus 5, right? X minus 2, x plus 5, and then that equals 0. And then you're going to FOIL that together, x squared plus 3x minus 10, and then we talked a lot about how it has to be an equation, so it has to be equals 0. We even did some harder ones with square root answers, x minus root 3, x plus root 3. This one's kind of nice because what happens to the inner and outer terms? Right, they cancel out, right? And then what's the square root of 9 again? 3, so equals 0. Also correct to say x squared equals 3. Now we're doing triples, right? We're doing cubic equations, so we have 3 roots. So it's the same process, but there's more foiling involved. Usually I would FOIL like those two first, so that's going to be what? X squared plus 2x minus 3 equals 0. And then do all this foiling, x cubed plus 2x squared minus 3x minus 2x squared minus 4x plus 6. And so when it's all said and done, I get x cubed minus 7x plus 6 equals 0. Okay. So a little rule that you may have noticed, I've never really said it officially, but crazy roots come in pairs. Crazy roots come in actually what we call conjugate pairs, where one is positive and one is negative. So we just did one with what I call crazy roots here. Positive root 3, negative root 3. Why do those always come together? Where do crazy roots come from? Right, crazy roots come from the quadratic formula. What does the quadratic formula have right in the middle of it? Plus minus, right? That plus minus. So that's where those crazy roots come in pairs comes from. Okay, yeah, I accidentally finished this entire thing and I didn't save it. So yeah, I get to erase it and redo it. Good times, right? Good times. Yeah, that's just how it goes sometimes. Okay, so where were we? I believe I was up to here where I said that they come in conjugate pairs, right? I'm just going to leave that number 4 and kind of explain it if I hadn't done that one yet. X equals 2i, negative 2i, those are conjugate pairs. I change them back into the factors, right? FOIL it together, end up with x squared plus 4. Now we've got 5 and 6. We actually almost did these when we were doing quadratics, but we let it go because it was just a little bit too much at the time. So now we have to do it anyway. X minus 1 plus I and x minus 1 minus I are the two factors that give us those roots. We could FOIL right from there, but it's a little bit much, so we're going to make our lives easier by doing something called distribute and regroup. If I distribute, I get x minus 1 minus I and x minus 1 plus I. And I can regroup like this. So then when I FOIL, first, outer, inner, last, I get x minus 1 times x minus 1, plus I times x minus 1, minus I times x minus 1, minus I squared. What's always going to happen to those inner and outer terms? Right, they're going to cancel out. So I just get x squared minus 2x plus 2 equals 0. That's the quadratic equation that gives those roots. And I could check that if I wanted to by quadratic formula. Let's try another pair of crazy conjugate pairs. This comes from the factor x minus the quantity 2 plus root 3 and x minus the quantity 2 minus root 3. I'm going to distribute and regroup, so I'm going to distribute here, and I get x minus 2 minus root 3, x minus 2 plus root 3. There's a lot of temptation to skip steps here, but honestly, people mess it up when they do. When I do first, outer, inner, last, I know my first is x minus 2 times x minus 2. I can just let the outers and inners go because I know that they're going to cancel out anyway, right? And so my final answer, x squared minus 4x plus 1 equals 0. Did I do that right? I think so. Yep. Great. Okay, last one, grand finale. This one gives me that x equals 1 plus 4i is a root. I know that there's 3 roots, right? Because it's got the third power. Crazy roots come in conjugate pairs. So if 1 plus 4i is a root, I automatically know 1 minus 4i is a root. So I only have to find that third root. So again, I'm going to write the factors that it comes from, which, by the way, these are always negative signs here. Some people get confused on that. That's always a negative sign. Once I distribute it, I'm going to get x minus 1 minus 4i, x minus 1 plus 4i. Don't skip the steps in here or you will get all mixed up. When I do my foiling, I could FOIL first times first is x squared minus 2x plus 1. I can skip the outers and inners and then minus 16i squared, which is plus 16, right? So it's x squared minus 2x plus 17. What operation do I need to do to find that leftover factor? Wait for it, long division. Before we would always do synthetic division, right? But this is a crazy divisor, so I have to do long division. So this goes in x times. Now it's going to turn out nice, right? It just is. So I've got the simple answer heading my way. So this is going to turn into what? X squared minus 2x plus 17. Look at that. That goes in one time. You don't even have to bother finishing it up. You know that it's true. So the final answer there is -1. I know that's a harder problem. There is one like that on the test, so it'll take a little bit, but you have some practice opportunities on the homework. Our last section, turning zeros back into equations.